So ready and go. So in this one, what's the radius of this inscribed semicircle in this given triangle? Well, it's actually two ways of doing this. There's a longer, well, longish way, and a very quick way, almost by inspection, that you can find out the radius of this. First thing to notice is 1 root 2 means that's a right angle triangle. Then, probably, the next thing you would do would be put in its radius. And the obvious place to draw its radius is from the centre to that tangent point. And it's at this point you either notice something or you don't. You either notice a very simple feature of this, or you get sidetracked into saying, oh, similar triangles, because that's what you normally do. So I'll just go for similar triangles here. Well, if that's the radius, and that's the radius, and that's of length 1, then that side's 1 minus r. That's a right angle triangle, so is this. They obviously share this angle, which I happen to know is 45, but it doesn't matter because they share it. So you've got two similar triangles. So taking this one out and this one out, there's a pair of similar triangles. And then you can just start. Ratio of corresponding sides. R corresponds to 1, so r over 1 is the same as 1 minus r, the hypotenuse, over root 2. And then sort that out, and there's the answer. So root 2r is 1 minus r. Take this across, so it'll be plus r. So that's plus another 1 lot of r, so it's 1 plus root 2r equals 1. So r equals 1 over 1 plus root 2. That would be the answer, except you need to rationalise that denominator. And of course, to do that, you'd multiply the top and the bottom by the conjugate of this for the difference of two squares, which is 1 minus root 2. Well, obviously top becomes 1 minus root 2, and the bottom becomes the difference of two squares, so that's going to be 1 squared minus root 2 squared. That's negative 1. That'll reverse that subtraction to root 2 minus 1, so there's your answer. It's A. However, if I start again, examine that triangle and do the first obvious thing, which is to draw in that radius, which of course must be a right angle. And instead of leaping into thinking of similar triangles, you just look at the picture. Just for a second, you'll notice you've got a tangent kite. These two lines are tangents to the circle. That's the radius, that's the radius, which means these two sides must be the same. So if that's 1, that's 1. And if that's root 2 altogether, that part must be root 2 minus 1. And because you've got a 45-degree triangle here, from the 1, 1, root 2, it means it's isosceles. But it's isosceles by the two sides being 1, 1 anyway. Then this will also be, since that's 45, that'll have to be 45. This is also isosceles. So this radius then is the same as this. So the radius is root 2 minus 1. Straight away, there you go, A.